Okay, this is PDDuino running on running on a Adafruit feather attached to the M100 via feather mount board, and getting power from the BCR port. This BCR port USB power adapter. I have links for all of those, GitHub links in the video description. So this is all the pieces. You have this is the lowest spec Adafruit feather board with the SD card built in. There's two versions of this. There's one that has a Atmel 32U4 CPU running at 8 megahertz, very low end, something like 2K of RAM. And then there's an M0 version, which has more RAM, runs much faster, and it's a 32-bit board. But they both take the same, they're the same pinout, same form factor, and then the PDDuino Arduino code supports both. This is a feather mount, or MounT. It's basically takes the place of serial cable and an RS-232 TTL level shifter module. Takes the place of that. You have a male DB25 plug, pin headers to fit the feather board, and this is an early version that has actual sockets soldered on installed. The next version just has offset staggered pinholes to make a friction fit without an actual socket. So the board will sit lower, will sit almost flush as if it was soldered without having to solder it. And basically the board just has the wiring to the null modem wiring for the TX and RX pins, and the DSR and DTR pins going through a MAX 3232 chip, 5 capacitors that the MAX 3232 requires, going to the TTL pins on the Arduino, on the Adafruit feather. The Arduino code is looks at the DSR pin. DTR from the M100 becomes a DSR pin on the feather, and I just arbitrarily chose pin 6 for that. Pins 5 and 6 for DSR and DTR. So it asserts DTR when it's ready, so that TS-DOS will gracefully detect whether it's ready or not instead of just hanging, and correctly monitors DSR so that it detects when the MEM100 has the COM port currently open, so it can do TPDD2 style bootstrap by detecting the status of the DTR pin, DSR from the Arduino's point of view, detect the status of a DSR pin at boot up, and choose to go into the bootloader mode the bootstrap mode instead of the normal TPDD mode if it detects that the COM port's already open at startup. So, and it's not really doing it at startup, it's doing it immediately after initializing the SD card. So the way the TPDD2 bootstrap works is you run the basic command to open the COM port and start trying to read from the COM port, and then turn the drive on, and then the drive checks a bunch of things at power on, and if all the conditions are met, then it does the bootstrap, and then it doesn't do the bootstrap any other time. This is very similar, but doesn't happen right at power on. At power on, it it asserts DTR low to tell the M100 that it's not ready and waits for an SD card. And so if you power it on with no SD card installed, it keeps looping every half a second, checking for the presence of an SD card, and it holds off. It holds off deciding about doing the bootloader bootstrap until after it gets the SD card. So you can power it on, hook everything up, turn it on, go into basic and start the command, and have this getting power from the BCR port where it comes on when the computer comes on, and yet hold off on having it try to do the bootstrap by just not having the SD card installed. So you hook everything up, eject the SD card, turn the machine on, go into basic and start the run com 98N1ENN command, and hit enter, and then insert the SD card, and it will start doing the bootstrap. And that's all you have to do. After that, the bootstrapper runs, and that installs TS-DOS, and then you can immediately start using TS-DOS, because after it does the bootstrap, it resets itself, and then it goes into normal TPDD emulation mode, because the COM port will no longer be open. So when it resets itself, it will detect that the DSR pin is not high, and decide that, oh well, we're not in bootloader mode, bootstrap mode, we'll do normal disk emulation or TPDD emulation. So this is how we put it all together. Little awkward with one hand. And I'm going to put everything together except not installing the SD card. Okay, so that's everything right there. Nice, neat little package. So this will normally be a little bit shorter. The next, this is an earlier version that has socket headers installed, but really this will normally ride 1/10 of an inch away from the other PCB. It'll just be the thickness of the spacers of the pins, of the male pins. So it's a little thicker than normal right now. Alright, so that's basically the kit. It's going to be powered totally from the batteries within the machine. So now I'll turn this on. I've already done the hard reset, cold reset. So it's the RAM has been wiped and it's starting fresh. I did that before starting the camera because I can't do that with one hand. So I'll turn this on, and a light will start blinking here, which indicates that it's looking for an SD card. Alright, so it booted up, looked for an SD card, didn't find one. It's waiting half a second, looks for an SD card again, and the blink is each time it checks for an SD card, that's one blink, and then this slow steady blinking is indicating that it's waiting for an SD card. So to bootstrap, that's all you have to do is eject the SD card. Well, one other thing you have to do is place a file named loader.do on the root of the SD card. And loader.do needs to be an ASCII formatted basic file for for any DOS. It could be anything actually. It could be any basic program that will run. It's just, but you know what's useful is a loader file. So like you know DOS100.do extracted from the MCOM 1.8 APK for Android. APKs are just zip files. You can just download the APK, unzip it, and then there's a folder called assets in there, and there's loader files for TS-DOS for model 100, 200, and NEC. And so you just copy those three files out. They're called DOS100.do, DOS200.do, and DOSNEC.do. Just take one of those, copy it to the root of the SD card, and rename it loader.do. And they're called .do because they're ASCII formatted. They're basic files, but they're basic programs, but they're saved in ASCII format. So you have to name that .do. So that has been done. DOS100.do is on this card, and it's named loader.do. So when the Arduino code, after I insert the SD card, it will initialize the SD card, and then that's when it will check the status of the DSR pin. And if it finds that the DSR pin is high, then it will look for a loader.do file. If none exists, then it just won't do anything. It'll just go into normal disk emulation mode. If a loader.do file exists, it will start reading it. It will read it and copy it down the SD serial port into BASIC. So what you do is basically the same thing you do for TPDD2 or for all the other TPDD emulators that have bootstrappers, which is MCOM and DL+. They all work the same way. You go run COM 98N1EN. Alright, it's 98N1. You could also do 98N1ENN, and that's a little more universal. The extra N is not meaningful on a 100, but the 100 ROM ignores it, so it doesn't make a bad command. On a 200, you need the extra N. So this is one command that works the same on both. And then for NEC, it's a totally different format. It's I forget off the top of my head what it is, but the DL Plus program has pre and post install directions for all the different loaders, including the proper format for this com command, run com command for NEC. So let's see. So that's the command. So basically, you start with the machine powered on with no SD card installed, and enter that command, hit enter. Now the COM port has been opened. It's currently, I hit enter. You didn't see me do that, but I hit enter. So the COM port's open, and it's trying to read from the COM port. And so now, if I install the SD card, insert the SD card, it will do its check for the DSR pin and decide to start sending the bootloader bootstrap. That solid light, the quick 3 flashes was initializing the SD card and signaling that we got an SD card, and then the solid light it's sending loader.do right now. So it takes a while because the TS-DOS loader is a large file, and this bootstrapper sends the file pretty slowly. It sends it one character at a time with something like 5 milliseconds, I think, between characters. I forget. There's a delay in between each individual character, and that just guarantees that it's slow enough that it will work and arrive correctly on the M100, regardless of flow control, regardless of speed, regardless of it's like a brute force making it go slow enough so that it's guaranteed to work. And then, okay, it's done sending the loader file. Now that loader code is running. So we'll start seeing some progress dots here. This takes quite a while. And it's running completely off of its batteries. And that's only drawing about under 20 milliamps right now. And when it's idle, it draws under 2 milliamps. A little bit better. The board, the adapter board, is performing a little bit better than the previous combination of breadboard and external serial cable and external RS-232 module. The dots get to about halfway through this second line, and that's when it's done. Okay. Okay. So this BA file that it just saved is really only one line. It's just a call. It's a call command that calls an address. So the real binary has been installed in memory. And there you are. It works. So it transferred clean. Let's kill this temp file. And the Arduino immediately after completing the bootstrap routine reboots itself, and on reboot it goes right into normal TPDD mode. So right now it's currently asleep, waiting for activity on its RX pin, and it wakes up and processes the traffic just by it's a hardware interrupt, and it wakes up, and processes. It doesn't even miss the first byte of traffic, which wakes it up. It even processes that first initial byte. So it sleeps very well. Like I say, 2 milliamps. And so I'll press F4 to read the disk directory, and I got nothing. Why did I get nothing? Interesting. Why do I have no contents on my SD card? So much for that claim. That's the first time I've seen that happen, actually. That's the contents of the SD card. And we got little niceties like, aside from the hardware sleep, low power mode, the top right corner here displays the directory, the current working directory in the SD card. So right now we're at the root of the SD card, so it says SD:. But if I go into any of these subdirectories, it shows that directory. And so we'll go into the PG design directory, which has the special driver program to make PG design memory expansion work. But anyways, I'm in PG design directory now, and it says so there. When I go back out to the RAM, exit TS-DOS and go back to the RAM file system, oh no, not when I exit TS-DOS, still have to be in TS-DOS. But when I go to the RAM file system, still in TS-DOS, it shows that although we're not looking at the SD card directory right now, this still shows you where you are in the SD card, so that when I go to save a file, I'll know that that's where it's saving to. That's a TS-DOS feature. And then, yeah. So I'll go back up a directory. SD. Util. Now I'm in util. Okay. And now just to show that the difference that it's correctly actually reading that DSR pin, and the DSR pin is reflecting the status of the COM port. Like if you're, it's correctly detecting that you're in BASIC and have opened the COM port or have not opened the COM port. So right now I'm not in BASIC, I'm not running that run COM command, and I'll power cycle the machine, and it won't go into the bootloader this time. Just the quick flashes was it detected the presence of the SD card, initialized it, flashed a couple times to show that, and now it's just asleep waiting for TPDD commands. So because I wasn't in it, I didn't have the COM port open, and it correctly judged that. So I could do it again. The power cycle, you have to power it on without the SD card in. So, because it only does the check once, you can't go back. So now it's waiting for an SD card because I just power cycled it without the card in. I can just do the same thing again. All right, COM port's open. And it's doing the bootloader. Except I'm not going to let it finish that. That's pretty much that. if I had anything else to say about this, but I have an updated version of this board. Like I said before, this is an earlier version that I just have some minor refinements just to make it neater, but this one is electrically correct. Just without that, there's a pull down. I had a pull down resistor on one pin, which turned out to be not necessarily wrong, but not needed. So I removed it. So this particular board just doesn't have the resistor installed, but the next board doesn't have the pad there. And like I said before, the new version has a different power switch. It has a low profile power switch that will sit along this side so that you can turn it on and off while it's plugged in. You'll be able to feel it and move it on and off. And you only need the power switch when you have a battery. The way the battery works on this thing is that the battery circuit on here, the battery plugs into the JST port, and normally the only way to disconnect the battery is actually unplug the battery, which you don't want to be doing all the time. You'll kill the connection. You'll kill it's just a cheap little JST crimped on wire that's won't survive very many pulls before the wire breaks. So you really want to just, if you're going to use a battery, plug it in and leave it plugged in. But then you need some way to turn it off, and they don't provide pins to turn it off by physically disconnecting the battery. What they do provide is a pin that connects to the enable, the EN, the enable pin of the voltage regulator that provides the 3.3 volts. So the way you turn it off without disconnecting the battery is you connect that enable pin has a pull-up resistor on the board already, and you override that by connecting the pin to ground, and that disables the voltage regulator. And that's how you turn the battery off without disconnecting the battery. So that's what the power switch does on here, is it just connects to that enable pin. If you don't have a battery, it does nothing. Well, it would still shut the voltage regulator off, but you have no reason to do that without a battery. Anytime you turn the computer off, it's going to lose power anyway, so it doesn't matter. You only need the power switch. If you have a battery installed, don't want to unplug it, you need a way to turn it off. So but this power switch is kind of difficult to get at, especially when it's plugged into the computer. It faces right into you can't get in there and touch the face of that. If it's unplugged, you can get at it pretty easy, but so the new power switch is a thin one that mounts right here, and it's thin enough. It's the same, it's as thin as the height of those black insulators on those pins right there, right? That's 1/10 of an inch. The new power switch is thin enough that it will fit in between the two PCBs without these tall sockets. So if you were to put this all the way down as far as it could go, whether you're going to solder it or just leave it friction fit, it's only 1/10 of an inch away from the other PCB. So the new power switch fits in between those two space, and all those components do too. They're all shorter than that. So that will make a nice tidy little package. And then the footprint, the new footprint, will not be, instead of perfectly straight pin rows, they're staggered. Each hole is offset by 12 thousandths. And that's just enough to make a nice solid friction fit that makes good electrical contact and good mechanical fit, friction fit, without an actual socket. And so That will be that.